Well, hello, welcome back. Another exciting note session, this time on operations with functions. Basically what that means is we take two things and we add, subtract, multiply, or divide them. It's combining like terms, and it's exactly like you think it means. So when you add, you really just add. Subtract, you really just subtract them, and so on to multiply. But the issue is the domain restrictions. And you're going to have some, and that's the part that you have to pay attention to. So the domain restrictions only occur occasionally, which is nice, which means we don't always have them. So a domain restriction will occur when you have a zero in the bottom, so no zeros in the bottom of a fraction, or if you have a negative number under the radical. So basically, we're going to have to set the denominator, set this not equal to 0, and we're going to have to take anything under a radical and set that greater than or equal to 0 so that it doesn't turn out to be negative. And we'll go through both of these here on this video, in case that's confusing right now. But first, let's go back to just going over what this means, the operations themselves. So you don't add the names. The F and the G are kind of gone. We don't add the names. Instead, we add the parts. So we're just going to add up the variable. So then we have x plus 1 plus x squared minus 1. Just combine like terms, x squared plus x. The ones are gone. So this is the answer. And then the domain is all reals. We don't have any fractions. We don't have any radicals. You can write all reals like that with that extra line in the R, or you could actually write all reals, or you could write negative infinity to infinity. Completely your choice how you indicate that it's all reals, but you do have to write that you know that basically every number works. For subtracting, pay attention to the order. We have x plus 1 minus, in parentheses, x squared minus 1. Distributing the negative is important because it changes the meanings. So we have x plus 1 minus x squared plus 1 again. So then this ends up being x squared plus x plus 2. No fractions, no radicals. All reals is our domain. Multiplying, I'm going to put it like that and just multiply my binomials together. So x times x squared times 1, x times negative 1, and 1 times negative 1. That is in the correct order, so I don't have to rewrite it. There is no like terms. We have no fractions. We have no radicals. Now, unfortunately, with division, you create a fraction. So you're going to have a domain restriction. It's just the way it is. It's pretty easy to write the problem, though. All you do is put one on top of the other. Just make sure you put the correct one on top and bottom. Now, this does factor. So we'll factor it. It's difference of two squares. And they cancel. So the answer is 1 over x minus 1. But we've created a new a new denominator. You have to use the original and any other denominator that happens to come about. So I'm going to start here with the original. And so at the beginning, I said you had to take that and set that not equal to 0. So I'm going to say x squared minus 1 cannot equal 0. So x squared cannot equal 1, which means x cannot equal plus or minus 1. If you look at the answer, this domain in the answer really comes from, the denominator really comes from the denominator in the question. So we haven't added any new information. In fact, we've taken something away. But you have to use the most restrictive environment. So this is going to be x cannot equal positive and negative 1. That is our domain, which you can label with a D. Now our issue really becomes square roots. They're generally the hardest kind, which is why I want to show them to you. So we're going to start, we can see we have a square root, so I'm just going to start right from the beginning, and I'm going to say, okay, this thing, the stuff underneath the radical, has to be greater than or equal to 0, which means x has to be greater than or equal to 1. This is my domain restriction for every single answer, unless another more restrictive environment comes up and I have to include other things, which that may happen, it may not happen. Now, the operations here will be simple because we can't do much with this. So in order to add these, we have x squared plus 6 plus the square root of x minus 1. You can't do anything with that. The domain, x is greater than or equal to 1. Subtracting, you'll feel the same way. X squared minus 6 minus the square root of x minus 1. Domain again, x is greater than or equal to 1. Multiplying, now this, we're going to multiply this. You may argue and say you can't really multiply it, and you really can't, but we can sort of distribute it and clean it up a little bit. So x squared times the square root of x minus 1 plus 6 times the square root of x minus 1. We haven't added any new information. By that I mean there's not another denominator, there's not another radical, so our domain restriction will continue to be the same. Now division. We already kind of know what's going to happen. We're going to create a new problem. We're going to create another denominator. So we'll put the f on top of g. And of course, now we have a radical in the denominator, which you know you can't have. So we'll multiply the top and the bottom by itself. Good news is we've already done the numerator. We just did it. So I know what that is. So this is x squared times the square root of x minus 1 plus 6 times the square root of x minus 1. And the denominator is just plain old x minus 1. Well, this denominator has the restriction as x is greater than or equal to 1. Our answer is a new denominator. There's no radical. So I have to come up with my new restriction. So x minus 1 is not allowed to equal 0 because there's no radical there. So then we get x cannot equal 1. Well, you have to combine these two. You can't just write out all these little separate parts of the domain. So our domain would then be, if we combine them, x is greater than or equal to 1, but it's also not allowed to equal 1, so it's just going to be x is greater than 1. A piecewise function isn't any real difference. You just have to do it twice. Keep the pieces where they came from. Top stays on the top, bottom stays on the bottom. We're adding p and q together. Domain restrictions out here stay the same, unless, of course, you create a fraction or a radical. So we'll start with our bracket, and then we end up with 2x plus 5. When we add that together, x is less than 0. When we add up the bottom, we get x squared plus x plus 3, and we have x is greater than or equal to 0. Now subtracting, I'm going to go off to the side here. So we have to do x plus 2 minus x plus 3. X plus 2 minus x minus 3 ends up with just -1, which is weird. No letter, but that's okay. So this top part is going to be -1 if x is less than 0. To subtract the bottom, you can tell that the signs are going to just be distributed. So x squared minus x plus 3 will turn into x squared minus x minus 3. And this is if x is greater than or equal to 0. Now I skipped this, but in both cases, the domain is all reals. We don't have any fractions or radicals. Multiplying, we're going to multiply x plus 2 times x plus 3. And we get x squared plus, add that up, the 2 and the 3 add up to 5, the 2 and 3 multiply to give you 6. If x is less than 0, and then when you multiply this one, we're just distributing. So we have x squared times x plus 3 this way. Don't just leave it like this, you got to multiply it out. So we have x to the third plus 3x squared if x is greater than or equal to 0, and again our domain here is all reals. The domain is not going to be all reals for this last part. So we have our bracket. In order to make the fraction, we do x plus 2 over x plus 3. And the bottom is going to be, the situation is how we graph it. This is if x is less than 0. And then we have x squared over x plus 3. And this is if x is greater than or equal to 0. Now we do have a domain restriction. This tells you where to graph. That's not our restrictions. That tells you what locations to plot the points. The domain is that we take the only denominator and we say that that cannot equal 0. So we get x cannot equal -3. So our domain is all reals except -3. Or you can say x cannot equal -3, which would really only impact one piece of our piecewise function. We just have a little open circle there, a little hole. So be sure to do your homework, Make sure you check your answers, jot down any questions that you have. Just bring all those questions into class or stop by in office hours in order to have your questions answered.